A lightning rod or lightning conductor is a metal rod or metallic object mounted on top of an elevated structure, such as a building, a ship, or even a tree, electrically bonded using a wire or electrical conductor to interface with ground or earth through an electrode, engineered to protect the structure in the event of lightning strike. If lightning hits the structure, it will preferentially strike the rod and be conducted to ground through the wire, instead of passing through the structure, where it could start a fire or cause electrocution. Lightning rods are also called finials, air terminals, or strike termination devices. In a lightning protection system, a lightning rod is a single component of the system. The lightning rod requires a connection to earth to perform its protective function. Lightning rods come in many different forms, including hollow, solid, pointed, rounded, flat strips, or even bristle brush-like. The main attribute common to all lightning rods is that they are all made of conductive materials, such as copper and aluminum. Copper and its alloys are the most common materials used in lightning protection. History. The principle of the lightning rod was first detailed by Benjamin Franklin in Pennsylvania in 1749, who in the subsequent years developed his invention for household application and further improvements towards a reliable system around 1760. As buildings become taller, lightning becomes more of a threat. Lightning can damage structures made of most materials, such as masonry, wood, concrete and steel, because the huge currents and voltages involved can heat materials to high temperature, causing a potential for fire. Russia. A lightning conductor may have been intentionally used in the Leaning Tower of Nevyansk. The spire of the tower is crowned with a metallic rod in the shape of a gilded sphere with spikes. This lightning rod is grounded through the rebar carcass, which pierces the entire building. The Nevyansk Tower was built between 1721 and 1745, on the orders of industrialist Akomfeed Demidov. The Nevyansk Tower was built 28 years before Benjamin Franklin's experiment and scientific explanation. However, the true intent behind the metal rooftop and rebars remains unknown. Europe. The church tower of many European cities, which was usually the highest structure in the city, was likely to be hit by lightning. Early on, Christian churches tried to prevent the occurrence of the damaging effects of lightning by prayers. Peter Allwartz advised individuals seeking cover from lightning to go anywhere except in or around a church. There is an ongoing debate over whether a meteorological machine, invented by Premonstratensian priest Prokop-Divis and erected in Primitica in Bohemia in June 1754, does count as an individual invention of the lightning rod. Divis's apparatus was, according to his private theories, aimed towards preventing thunderstorms altogether by constantly depriving the air of its superfluous electricity. The apparatus was, however, mounted on a freestanding pole and probably better grounded than Franklin's lightning rods at that time, so it served the purpose of a lightning rod. After local protests, Divis had to cease his weather experiments around 1760. United States. In what later became the United States, the pointed lightning rod conductor, also called the lightning attractor or Franklin rod, was invented by Benjamin Franklin in 1749 as part of his groundbreaking exploration of electricity. Although not the first to suggest a correlation between electricity and lightning, Franklin was the first to propose a workable system for testing his hypothesis. Franklin speculated that, with an iron rod sharpened to a point, the electrical fire would, I think, be drawn out of a cloud silently, before it could come near enough to strike. Franklin speculated about lightning rods for several years before his reported kite experiment. This experiment, it is said, took place because he was tired of waiting for Christ Church in Philadelphia to be completed so he could place a lightning rod on top of it. In the 19th century, the lightning rod became a decorative motif. Lightning rods were embellished with ornamental glass balls. The ornamental appeal of these glass balls has been used in weather vanes. The main purpose of these balls, however, is to provide evidence of a lightning strike by shattering or falling off. If after a storm a ball is discovered missing or broken, the property owner should then check the building, rod, and grounding wire for damage. Balls of solid glass occasionally were used in a method purported to prevent lightning strikes to ships and other objects. The idea was that glass objects, being non-conductors, are seldom struck by lightning. Therefore, goes the theory, there must be something about glass that repels lightning. Hence the best method for preventing a lightning strike to a wooden ship was to bury a small solid glass ball in the tip of the highest mast. The random behavior of lightning combined with observers' confirmation bias ensured that the method gained a good bit of credence even after the development of the marine lightning rod soon after Franklin's initial work. The first lightning conductors on ships were supposed to be hoisted when lightning was anticipated, and had a low success rate. In 1820 William Snow Harris invented a successful system for fitting lightning protection to the wooden sailing ships of the day. But despite successful trials which began in 1830, the British Royal Navy did not adopt the system until 1842, by which time the Imperial Russian Navy had already adopted the system. Nikola Tesla's U.S. patent 1,266,175 was an improvement in lightning protectors. The patent was granted due to a fault in Franklin's original theory of operation. The pointed lightning rod actually ionizes the air around itself, rendering the air conductive, which in turn raises the probability of a strike. In 1919, many years after receiving his patent, Tesla wrote an article for the Electrical Experimenter entitled Famous Scientific Illusions, in which he explains the logic of Franklin's pointed lightning rod and discloses his improved method and apparatus. In the 1990s, the lightning points were replaced as originally constructed when the Statue of Freedom atop the United States Capitol building in Washington, D.C., was restored. The statue was designed with multiple devices that are tipped with platinum. The Washington Monument also was equipped with multiple lightning points, and the Statue of Liberty in New York Harbor gets hit by lightning, which is shunted to ground. Lightning protection system. A lightning protection system is designed to protect a structure from damage due to lightning strikes by intercepting such strikes and safely passing their extremely high currents to ground. A lightning protection system includes a network of air terminals bonding conductors and ground electrodes designed to provide a low impedance path to ground for potential strikes. Lightning protection systems are used to prevent or lessen lightning strike damage to structures. Lightning protection systems mitigate the fire hazard which lightning strikes pose to structures. A lightning protection system provides a low impedance path for the lightning current to lessen the heating effect of current flowing through flammable structural materials. If lightning travels through porous and water-saturated materials, these materials may literally explode if their water content is flashed to steam by heat produced from the high current. This is why trees are often shattered by lightning strikes, because of the high energy and current levels associated with lightning, and the very rapid rise time of the lightning strike. No protection system can guarantee absolute safety from lightning. Lightning current will divide to follow every conductive path to ground, and even the divided current can cause damage. Secondary, side flashes, can be enough to ignite a fire, blow apart brick, stone, or concrete, or injure occupants within a structure or building. However, the benefits of basic lightning protection systems have been evident for well over a century. Laboratory-scale measurements of the effects of any lightning investigation research do not scale to applications involving natural lightning. Field applications have mainly been derived from trial and error based on the best intended laboratory research of a highly complex and variable phenomena. The parts of a lightning protection system are air terminals, bonding conductors, ground terminals, and all of the connectors and supports to complete the system. The air terminals are typically arranged at or along the upper points of a roof structure, and are electrically bonded together by bonding conductors, which are connected by the most direct route to one or more grounding or earthing terminals. Connections to the earth electrodes must not only have low resistance, but must have low self-inductance. An example of a structure vulnerable to lightning is a wooden barn. When lightning strikes the barn, the wooden structure and its contents may be ignited by the heat generated by lightning current conducted through parts of the structure. A basic lightning protection system would provide a conductive path between an air terminal and earth, so that most of the lightning's current will follow the path of the lightning protection system, with substantially less current traveling through flammable materials. A controversy over the assortment of operation theories dates back to the 18th century, when Benjamin Franklin himself stated that his lightning protectors protected buildings by dissipating electric charge. He later retracted the statement, stating that the device's exact mode of operation was something of a mystery at that point. Originally, scientists believed that such a lightning protection system of air terminals and downleads directed the current of the lightning down into the earth to be dissipated. However, high-speed photography has clearly demonstrated that lightning is actually composed of both a cloud component and an oppositely charged ground component. During cloud-to-ground lightning, these oppositely charged components usually meet somewhere in the atmosphere well above the Earth to equalize previously unbalanced charges. The heat generated as this electric current flows through flammable materials is the hazard which lightning protection systems attempt to mitigate by providing a low-resistance path for the lightning circuit. No lightning protection system can be relied upon to contain or control lightning completely, but they do seem to help immensely on most occasions of lightning strikes. Steel-framed structures can bond the structural members to earth to provide lightning protection. A metal flagpole with its foundation in the earth is its own extremely simple lightning protection system. However, the flag flying from the pole during a lightning strike may be completely incinerated. The majority of lightning protection systems in use today are of the traditional Franklin design. The fundamental principle used in Franklin-type lightning protection systems is to provide a sufficiently low impedance path for the lightning to travel through to reach ground without damaging the building. This is accomplished by surrounding the building in a kind of Faraday cage. A system of lightning protection conductors and lightning rods are installed on the roof of the building to intercept any lightning before it strikes the building.